As I'm sure you've heard by now, IPLCheck has been withdrawn from the market. That naturally leads to the next question we've been hearing the most, which is what's next? So today's really about answering that. So, Paul, where do we start? What is next?
Okay, well, thank you, Sammy, for setting the stage here. I think it's a good topic for us to be discussing with our customers and prospects. IPL Check AI is essentially an AI agent that's designed to help you to perform a number of different tasks relative to your position as an auditor, perhaps a security person, or perhaps a systems programmer. It's enhanced beyond the capability that IPL Check had by support for ZOS 3.2, a full integration, a pipeline, if you would, into the IBM Health Checker for ZOS so that we can report on its exceptional findings. The ability to detect dynamic changes along the IPL path, things like changes in system symbols or the LPA list, linked list, etc. Has a fully integrated development environment that gives you broad capability to explore the data that it's capable of producing in its trace, sometimes referred to as a log. It provides baselining capability so that you can actually measure the drift that an image might be having across time relative to a baseline. And a number of reports, we call them reporters, and schedulers, different ways of scheduling things, either using the health checker or an internal scheduling mechanism or your own job scheduler, and a number of unique delivery methods, not only email, both secure and unsecure email, but also FTP, secure and unsecure FTP, as well as access to portals like ServiceNow, as an example. So there's a substantial number of enhancements in IPL Check AI over and above what was available in IPL Check. So the question always is, so how much? And I'm not going to wait till the end of this in order to present that. I'm going to go ahead and do it now so that you have an idea of what this might cost you. The idea here is that there are really two forms of licensing. One is the normal perpetual license, which would be $25,000 for the first year, and then after that, 18%. Of course, if you couple this with also the acquisition of Image Focus, if you don't already own it, the cost would be $37,500. If you're already an Image Focus user, IPL Check is essentially included with that license. But in addition to that, there is also a new licensing feature, which I'll talk to in just a minute. The second form of licensing is essentially to enter into an annual rental agreement. And in that case, it's $2,000 per image with a minimum commitment of 2 years and a conversion to perpetual at any point in time along the way. So you can get into it if you're new, license a couple of images on an annual basis, see how it works, and then at some point during that process, decide that you want to convert to a perpetual license, and we'll arrange a credit for all of the payments that you've made up until that point. In addition to the normal licensing features that you might be familiar with New Era, there is an additional activation of each image that will come under the auspices of IPL Check AI. And that new code will be placed in the NSE PRM member as a value on a variable called mpost. And we can spend more time on that discussing it if you want to get into a deeper dive and what that all means. So what's in the package? Well, IPL Check AI really is the integration of 3 specific data types into a single view. Findings, of course, those are the errors, warnings, and notices produced by Image Focus. exceptions. Those are the high, medium, and low exceptions as produced by the IBM Health Checker for ZOS, and changes, which are adds, deletes, and obviously changes in members that are discovered along the IPL path that are a part of the new baselining feature that we've made available within it. The important thing to keep in mind as we talk about this is that there's nothing experimental about this particular AI. This is rule-based AI that produces facts, well-defined facts that are disciplined and provide operational intelligence. This is not generative AI where there's a guess or based on probability or based on the analysis of large volumes of data in order to come to conclusions. This is straightforward, the if then else kind of AI that we've been practicing for some time. So it runs on-prem. It's not a server. It's not anywhere other than on the LPAR that falls under its control. In order for it to do its job, the AI needs essentially two things. It needs a brain and it needs some tools. The brain is actually image focus. It's trained to support 3.2. It can support fine tuning. You'll hear me refer to those as weights that you can adjust to groom the AI to fit your own specific needs. It has well over 2,000 if-then kind of rules within its rule set and numerous numbers of rules that it pipes into ZOS in order to extract information from it in real time. It has a number of feature groups, which we'll talk about, and its predicted outcomes are 4: errors, warnings, notices, and everything's okay. Those are the simple truth about what image focus is actually capable of doing. The tools are essentially a 3270 interface that provides you with a way of exploring the data and performing data analysis to gain insight into what the actual results are from an inspection. It's a command line interface to the trace and the log for exploration. It reports different types of information in reports. There are well over 20 of those. And it has a number of different delivery methods and a number of different dashboards that are intended to support its primary findings. Again, findings, exceptions, and changes. It can operate autonomously. It can be self-driven if you choose to do it that way, or it can be run under the direct control of the IBM Health Checker for ZOS, or it can run under your external job scheduler, again, if you choose to run it that way. So the impression so far might be that there's a lot of options here, and that's true. And lots of different ways that you can groom this to support your environment in the way that you want it to be supported. So let's take a closer look at the brain. Actually, like most AIs, it's designed to solve a complex problem. In this case, the problem statement is there anything along the IPL path in an existing image as known by ZOS 253132 that might result in a failed initialization the next time I push the button during during an IPL. Our data scientists, sometimes called system programmers, have trained the model through years of experience, their experience, from IBM documentation, from input from customers all around the world, from the examination of literally thousands of inspection logs over the last few years, in order for this model to perform in a way that they believe will provide the answer to that question. Is there anything that will result in a potential failure, a brownout, some difficulty within the next IPL cycle? In addition to those rules, there are also rules that allow it to pipeline information from ZOS directly into it. And again, this runs totally on-prem. Those findings from the pipeline itself are matched against the rules to determine if something might be untoward. That finding, if you would, then brings you into the picture as a decision scientist, because you are the one who will ultimately have to make the decision as to whether or not the solution to this complex problem resulted in something that's smart, something that can give you a prediction of the future that can lead to action now, that can help you to avoid a problem in the future when you next push the button. It could be reported as an error, it could be reported as a warning or a notice, or it could be reported as a dynamic change, that is something that's changed in the APF list or the link list or in the system symbols that changed dynamically, that if it's not included in the configuration before the next IPL will result in a reversal back to the original IPL structures that obviously you didn't want because you made these dynamic changes in the meantime. So it's quite robust, but it's dependent on two groups of people, those here at New Era that we call data scientists, and those in your organization that we call decision scientists, people who are able to make that determination that in fact these findings did something smart. And in those cases where you find something that you don't think is such a smart idea, you can either filter it out through rates, or you can report it to us and we'll work with you to either create a level of understanding of how we did it, or perhaps we'll make a correction to the product itself. We do that from time to time. So what's the role that you play as the human in the loop? Well, the most important role is to make sure that biases that are key to your organization's understanding of the findings get implemented into the rule set in the form of weights. Now, this is reinforcement learning with the help of a human being, human feedback, if you would. You're looking at the results, you're saying, hey, that's not exactly how I want that to be reported. I don't need that to be a warning. I would like to see it as an error. Or I don't see it as informational. I would like to see it as a notice or as a warning, whatever the case may be. Those weights are easily added to the rule sets themselves, so that the tool itself begins to learn from those things that you believe are important in your organization. And they take precedent over the defaults themselves. You can create a multi-image repository of traces. We call that an ensemble, and I'll show you an example of that. That allows you not only to examine the traces and logs of a local system or a local sysplex, I'll share one of those with you as well, but also the logs from remote systems that might be in different locations or on different CPUs that you are piping in to a common repository to create an ensemble of multiple images. Of course, across all of those at any point in time, all of their results, inspection results, dynamic change results, exceptions from the IBM Health Checker, or member changes can be analyzed in the form of a dashboard. The intent of those dashboards is to provide you with a way of exploring the data from an analytic perspective to gain insight into a specific image, a comparison of that image to its baseline, or what we call the gold image, or a comparison of one image against another that may be in completely different systems. The results of this not only can be examined in real time through the EDA, but also transported via email, FTP, or services like ServiceNow in a number of different ways, either secure, unsecure, or some other method, not ServiceNow, but something else that might be more appropriate for your particular organization. So lots of options, lots of things that we can do with the tools that are available to us from the system itself. The final result of logging on to this, and we'll do this in just a moment, under TSO ISPF from the command line, gives us the opportunity to generate these dashboards. They're all presented in line with each other and are able to guide you through your exploration of the data in such a way as to hopefully result in a more meaningful set of insights into what is really going on in the various ZOS environments that are represented here. So with that said, I'm going to go ahead and close this set of windows here and share my 3270 session that you can see now, hopefully. Now, as I mentioned, this is useful not only for simpler systems, let's say a sysplex, which you see on the screen right now, or for an ensemble of images, as you see on the screen now. So the sysplex representation, this one, is essentially a use case where we have IPLCheck AI running on a running on some hardware that has been configured to have 5 different images. And it is managing those images through this panel by collecting their logs in a commonly named format. So it's creating its own ensemble at this point of these 5 images. And the image that's actually running the process is the one that's shown in green, sys A. You can see it up here at the very top. And one of the baseline mechanisms that we have is to create a gold image, and you can do that automatically. I'll show you how that's done here in just a moment. And then you can compare these, as you can see up at the top. So we could compare this image, the gold image, against this image, our current one. They appear to be the same, so let's just try that and see what results. So you can see that in this case, it compared those two. It compared the gold image and all of its content. That gold image baseline is 18,000 records long, and it's comparable in size to the trace log that is currently in place, having been created on January 29th, 26 for sys A. So the gold image was created late in December of 2025, and the current image that it's being compared against was created this morning. And it finds no difference between those two. So that's probably a good thing. And you can see that in this report. It's showing us all of the findings, all of the dynamic change elements that we track from system symbols all the way down to RNL lists. It's telling us how many of those are there and the differences that exist between the two. So everything's pretty much the same here now at this point. Now we can move on and perhaps find another one. Let's do this one. Let's compare sys B. Excuse me. Tell me the problem. All right, let's make that comparison. Okay, so now we have a difference of 1 warning. Okay, now in our vernacular, errors, warnings, notices, and things that we issue as heads up are essentially risks that you're taking. If you don't resolve these, there is the potential that these might result in some sort of an issue in the next attempted initialization of your ZOS environment. And so because of that, we believe it's best to understand these and resolve them as soon as you possibly can. So let's see what the warning is. So the warning is that on system B, in comparison to the gold system, there is a warning that was issued that a member, command $, was not found in the Parmlab concatenation. Now, we can't drill down into that to any level deeper in order to be able to tell you what that substantially might mean. But we can give you this heads up that will allow you then to go into the member itself and begin to explore. Okay, so you could go find that guy, you could take a look at it, see exactly what it's all about. Let's see. Excuse me, I picked the wrong one. Oops. Well, I've just probably typed it in wrong. Let me not try to futz with that right now. But the idea is to make it easy for you to get to the key waypoints within the inspection trace in order to be able to determine the level of risk that might exist if that member, for example, isn't put appropriately into the IPL path. All right. Now, let me back out of this one and go to the ensemble. Now, the ensemble is quite different from the cisplex because these images may or may not necessarily be related one to the other. It's hard to know what the answer to that question is without direct examination. So the idea here is to present a picture in the form of these little sort of Lego-looking kind of cubes to make sure that you can come to a conclusion as to what is the same, what is different, what might be changing as quickly as possible. So let me go down one of these cubes so you can see exactly what it's trying to tell us. First of all, obviously we have the image name. Then, of course, we have the date on which the log was actually created. So this one's pretty old. What the findings were, errors, warnings, and notices in that log, and whether or not there were any dynamic changes. And in this case, there are none, so everything's the same. But on this particular log, that was created in September. So one of the takeaways that you might get from this immediately is that some of these images are not necessarily seeing their logs updated frequently. And maybe that's an issue that you want to put into play to find out why IPLCheck AI is not being run on some of these images as frequently as it would appear from the dates that we see here. This is all test data, so nothing to be alarmed about right now at this point. The gold image we talked about, the green image is the one that we're actually on. So we can have all these images in our ensemble, but we'll always point out the one that actually is driving the process itself. So if I put the cursor under SOW1, we'll see an additional deep dive into more detail surrounding SOW1 itself. So it's analyzing the log, and it presents us now with this view of the log content. So we can see when it was last run. This was this morning. We can see the name of the log itself. We can see the errors, warnings, and notices that are associated with this particular log. If we put the cursor under notices, for example, we'll see all of those. So we don't have to go and hunt through the log to find them. It not only gives us the line number, but it also gives us the image focus message number and the message that's directly associated with it. So it makes exploring the data substantially easier and brings to the front, if you would, those waypoints that are critically important to your understanding when you're exploring the data. Over on the right-hand side here, you see some little additional indicators. One of them is backup. Now, what backup is telling us is that there is a message in the log that says this: the control editor has made a verifiable backup of your system data sets. The first rule of system programming, in my opinion, is always have a backup. Always have a backup. Clearly, before you make a change, but even after you make a change and you believe that it's correct, that is, it's inspected cleanly, make a backup of it using the control editor, or in some cases, it will do that automatically for you, so that you can know that in the event of a problem, you can always restore back to a previous level. So this is integration with the control editor. So again, that green indicates that there is a verifiable backup. I mentioned weights earlier. If we decide that some of these warnings, these notices, and this informational message is not exactly how we would like to see things reported, we can change the weights. You can see one of the weight definitions now that's active here. We have IFO 5678N, and we want to change it to an error. Okay, so that's currently active and being applied. But if I hit PF3, it's going to come back and tell me that I have opportunity to update the weights. So I go to this panel now, and it says, okay, well, if you want to update a weight, simply put the message in this column, change the weight from a W to an I, tell me whether or not you want to match a specific set of text that's in the message itself by checking this, or if you're not happy with the message, check this, and actually put a new message in this for it to be changed to, and check that. And if I were to check this now and update the weights, now it gives us messages because there are guardrails here and warnings, if you would, that in this case, the IPLCheck admin is the only one that's permitted to actually make updates, and that's me. So here's now what our controlled member, this is it right here for these weights, actually contains. It now contains the message that we just put in it, changed to an I. We replaced it with this message, and we're essentially good to go. You might say, well, heck, how would I know all of the things that potentially I might want to change? You could click under Show All Messages in Text, and we'll give you a panel, a report actually, that will group all the messages together. So you can see there are no error messages in this particular log. There are 3 different warning messages that have been grouped together. This is one of them. This is the second one. And this, of course, is the third one that we can change if we choose to do it. This is a kind of interesting one. All of them are being enhanced to this level, but it not only tells us the line item that this particular message appears on, but it also gives us the name of the data set that is being examined and discovered not to have an appropriate data set profile. So if we want to go fix that, we can. If we want to change the message, we can, simply by doing what I showed you just a few minutes ago. Now I'm going to undo this by just simply unchecking that and updating the weights, because I want that to be recorded the way it is. If I go back down to the bottom, you can see that that now has been updated and activated, and we're good to go. So lots of opportunity for changing the weights on things to make this groom to the point that when you look at it and it says it's a warning and you wanted it to be an informational message, it's now informational. And that's what you want for your organization at this particular point in time. There's a lot of history type information that is maintained here. So we can check to see whether or not a particular configuration is being updated on a regular basis. This was updated for the first time today compared to previous time, which was at the end of last year. And you can see in some cases there wasn't even a baseline that had been created then at that particular point. Backing up. We show the date of the last IPL, the time, how old it is, and what release of ZOS we're running. We're running 2.5 in this particular case. The load parm, the load member, whether or not we have any dynamic changes. We don't have any in this particular instance. But if we did have some, we could adjust the weights of that as well. Here are the current weights that are in place. So what it's saying is that if you see this change in the LPA list, exclude it. And in order to make sure that you know that we actually found that and excluded it, we put an asterisk in the front of it. But there are some that we have in our exclude list, for example, RACD cert, that we didn't find. And you can see we put it in there. We were testing this a couple of times. They're in there, and we didn't find anything like that, and they haven't been excluded. Obviously, from here, we might decide that we want to do some additional excludes. You can review the exclude list as it currently exists, and there's nothing for us to exclude additionally at this particular point in time. If there were, we would be given an opportunity to look at those and then add them to the exclude list if we wanted to do that. Baselines, changes as an example. Here are a couple of things that we can pay attention to. Oops, sorry. You notice this message is kind of an interesting one because it is essentially giving us a heads up on a new message that has been added since the last log was actually created. In this particular case, it's telling us, or it could be a change in configuration, that this particular volume appears to be a secure boot problem, or a volume. We support that, secure boot. You just go down a little bit further here. And you can see in this pseudo member, which we call the IPL member, all of the IPL parms are laid out in their way in which they are defined and passed to ZOS during an initialization. And in addition to that, this new record has been added that lets us know that we have, in fact, a secure boot volume that, or appears to be a secure boot volume per se. Backing up. There are just tons of different discovery prompts that make compliance type reports, audit reports available. Some of them are really unique. One of them is IBM's program property table, which we often see in the form of the content of a member that are a module that's provided by IBM, but not necessarily in a report form as is being presented here. So this is a bit of an unusual presentation of that particular module. Here it is, IEF SDPPT. where it was found, et cetera, et cetera. And then here it is, if you would, decomposed and analyzed and presented in the form of a report. Some of the interesting things that we could do here is we could check this email function, produce the report again. When we PF3, it'll actually give us an email panel that will allow us to email that report to any number of people that we consider to be admins and have set up in this panel with that designation. So we're good to go here. Put your message, check your recipients, give it a title, and send it out as email. And again, that email can go either as a simple email or it can go as a communication server secure type email, depends on your setup. The PF3 back here. I got myself in a situation now. I got to get out. Okay. All right. Let me go back in there just for a minute. Again, what shows up in the ensemble is really up to you. You have to go through the process of setting that up. Guardrails, essentially facility class profiles intended to name specific administrators, privileges for users, privileges for auditors. We can get into the details of that if you like. They can be turned on and off as you see fit. So we have them off right now at this point. Again, we're in a development environment, lots of people jumping in there. Monitoring of all kinds. We can operate directly under the IBM Health Checker for ZOS, so we can check that and we can run it that way. The health checker might run frequently during the day. Ours is set to run every 2 hours. That's a bit annoying. So we have it set to a limit of 1, so it runs every night or at the beginning of each new day when the health checker runs and produces a report that's sent by the health checker to a set of recipients. Or we can simultaneously run it by day, by week, by month, and send it to a set of admins. These are the same admins I showed you earlier. Or we can create individual lists of individuals to receive emails directly from the system. This is a different list. So you could say, yes, I want to send weekly emails, but I want to send them to a different set of people or an additional set of people over and above those that I've identified as admin. Email can be, as we mentioned, both simple and secure. If you are using the communication server to send email, you'll need to define the writer name that is defined in the PARM, the communication server parameter. Ours happens to be IFO email. We can set that on or off as the case may be. It just depends on how we want to send this particular message. All the reports are live here. These are the ones that are run. The last ones were run on 1.9, so this morning. But if we were to look at the health checker as an example, here's what the health checker results look like. This is not obviously sent in the form of an email, but this is giving us an opportunity to explore more deeply the findings that the health checker has in store for us. You can see some RACF checks that are here. If we want to see all the RACF checks, remember, these are just high, medium, and low checks. If we want to see them all, then we can just put the cursor under RACF and it will display all the RACF checks for us. And then, of course, we can do the other 9 if we choose to do that. If we don't know exactly what these checks are doing, we can put the cursor under the the check name and press enter, and it will tell us exactly what that particular check is up to. So we don't have to go into SDSF, we don't have to go to CK, we don't have to try to drill down into the individual checks. We can find all of that information here. Again, we can find more history if we choose to do that. We could send the full log to somebody. We can send a dashboard report. In the ensemble, the dashboard report would summarize 16 different images, so that would take a while to build as we're defining the report. We can ask it to report only on changes, so we can check that and get that kind of thing going for ourselves. So lots of different ways in which we can drill down into the trace, not only to find specific information about its findings, errors, warnings, and notices, but also perhaps more mundane things like when was the last IPO? What was the unit address? What was the load parameter? Were there any dynamic changes? Had there been any configuration changes that were detected by baselining? Are there any compliance reports that are of interest that I might want to send to some of my team players to have them take a closer look at them, or to an auditor if we're asked to, let's say, give me a list of all the APF data sets and their sourcing of those data sets and whether or not they are secure. That information is available there. So I'm going to go back here to the Sysplex, because this particular Sysplex now has the availability of being able to see the current state and status of all of the IBM health checks. So I'm going to click on Show Exceptions. Now, this is a real-time activity. It's going off and examining its pipeline to the IBM Health Checker for ZOS and saying, hey, give me the current state of all of the checks. And so it's come back now and it says, okay, well, here's the current state. And your question might be, what in the world is going on here? I thought these were all going to be the same, but apparently they're not. This one has high, 9 medium, 8 low, 38 informational ones. What's the difference between these two? Well, we can compare those. And we can get an answer. And it will tell us specifically what the differences are, excuse me, between those two. And then from here, we can drill down into that to find out exactly what it is that it's finding. That seems to be untoward. Here's that particular difference. So on Sys A, there's a medium exception for this check owner, IBM XCF, under the check name of that. And again, you could drill down further in the report itself to determine whether or not that might be of significance or importance to you. We can show the baselines. Again, this is a real-time activity comparing each of the individual traces now to the baselines themselves that were established for each individual image. Each image can have its own unique baseline. Doesn't have to be the baseline of the gold image or any other image. Each one has its own. We can compare two images. And so we can find out exactly what's different between the two. We can show the differences in content. This is a Venn analysis that you see here. It's kind of interesting, but it's not the money shot. The money shot is what's the difference in the content? And we can show that for each of the individual members that have a difference, up to 72 in this particular instance. Here's what's different. So you can see in this particular case, the page up a little bit here so I can get the proper name. This member, IEA SIS or SIM X1 on system A is configured like this. But on system B, it's configured like this. And as the decision scientist, you're the only one who could really tell us whether or not that's important or not, or whether that insight gave you some, this report gave you some insight that was critical to your understanding of the differences between these two specific images. Oh, I did want to show you one other thing here. Let me go back. The other thing that's kind of interesting that's reported in this trace is when there are no differences between the content of a member, that is, they are identical, but there could be differences in the state status and update history of particular members. And that's what this is designed to do. Now, it's not reporting anything of significance here because these are essentially the same. But as we stop on member, that's number 24, you can see here that what it's done is telling us where it found it, what volume it's on, what data set it's in. And if they were different, you'd see a small v here and a small d. And let me quickly get back to this guy. Where I can show you what that actually would look like. So again, because I have two 3270 sessions going here, one with Sysplex as my use case and the other one as an ensemble as my use case, you could actually do both of these just as I'm doing it to get an insight into perhaps your local system and to the ensemble that you have or are putting together. So let's see if I can remember. I'm going to compare B to SOW1. Okay, so we have some differences. Of course, that would make the panel look like this. So we have a lot more members that we have to go find out what's different about the two, if that's of interest to us. But here's what's of interest here. You can see in this case, on this record number 5, the BPX PRM-RZ number, again, we have a date, we have a time, and a user. And there's no difference in the content of these members on these two different dates. But there is a difference in the date and the time and the user who last touched it. And so we might ask the question, what are you doing? What did you do? And instead of having to look at all of these individual dates and times and everything as the raw data, what's on the right-hand side is intended to give you the eye catchers that you need in order to understand essentially what's going on across this entire configuration. And the same thing is true for the status records. And you can see those down below. Okay. All right. So let me stop sharing this and go back to my 3270 session real quickly. So here's some of the takeaways from this particular presentation. This is rule-based intelligence that you can use as trusted data to better understand your ZOS environment. It's done instantly and differentiates the systems in ways that give you true insight into what is going on. But this is not generative AI. This is not a bunch of hype. This is something we've been doing for quite a long time. It's stuff you can trust. It's built for ZOS, runs on-prem so you can trust it, and provides intelligence to you without any guesswork. It's deterministic across your entire ZOS enterprise. So what's the next step? Well, I hope you would want to take it. We can do a much deeper dive if you're interested in that. We could do a proof of concept. If that's something that you can do, it's a no charge period for 60 days that gives you an opportunity not only to test IPLCheck AI, but to test our support of you while you're in that period of examination. A couple of final points. We've been at this for a long time, from when our CEO suggested that we do something to help resolve these kinds of problems by asking the computer to tell us what's wrong as opposed to beating it with a hammer, to now the emergence of IPLCheck AI, not only as a tool that looks at the results of image focus, but pipelines into the health checker and provides detailed methods for establishing baselines and goal systems that you can use for comparatives to identify configuration drift. I want to just point out that we have another webcast that's going to be announced that will occur early in February, where we're going to talk more about our AI family of TCE AI, Valboot AI, and then a brief refresher of IPLCheck AI.